GCSE Physics boosters, efficiency. That's what this video is about. It's about efficiency. Now consider this to start with. Here we've got a winch, might be like in a garage, used to pick up engines and things, but it's got an electric motor in it. Now it takes 30 seconds to lift a mass of 800 kilograms, a height of 2 meters. And I've given you a value for little g. Now, first of all, how much useful work does it do? Now, I'm assuming that you are revising and you know how to work out work. So there's a couple of ways you could do that, and then calculate its useful power. So work them out. So to work out the work, I've done work equals force times distance. I could have done mg times delta H, as in gravitational potential energy. You get the same answer, 16,000 joules. So that's how much useful work it does, 16,000 joules. And its useful power is work over time. So 533 watts, 533 watts. Now, the motor uses 1.3 kilowatts of electrical power. So why is the useful output power less than that? We're giving it 1,300 watts and it's using 533 watts usefully. Why is it less? Well, what's this video all about? What's happening is we are giving it electrical power. It is using up electrical power. We are getting useful power out, which is doing useful work, lifting up engines or whatever. But then some of this power is wasted. Okay, now it doesn't disappear because energy can't be created or destroyed. It just doesn't do useful work. What happens is that energy is lost due to friction, because inside the motor there's all kinds of bits and pieces rubbing against each other, and there's gears in there which are grinding against each other, and energy is lost due to friction. That produces heat, a little bit of sound as well, which dissipates into the surroundings. This word, it dissipates, it spreads out into the surroundings. So the surroundings, the room that it's in, will get a little bit warmer because the motor is in there. It dissipates, it spreads out into the atmosphere, into the surroundings. Okay? And basically, the efficiency of the motor is the useful power out divided by the total power in. In this case, the efficiency will be 533 divided by 1,300, or 0.41. Now, you can express it as 0.41, or you can say 41%. If you're using it in an equation, then it's 0.41, but some people may find it a bit more meaningful if you say 41%. That's the efficiency of this motor. Remember, efficiency is useful divided by total. Useful out divided by total in. Is there any way we might make our motor more efficient? Well, energy is lost due to friction. Is there any way we might be able to reduce the amount of friction? Maybe if we had a can of oil, you know, to kind of lubricate what's going on inside the mechanism. That might make it more efficient, might reduce the amount of friction. Here's a couple of calculations you can have a go at. Pen, paper, calculator. I'll show you my answers in 3, 2, 1. Okay, so the first one, a litre of petrol contains that much chemical energy. The engine does that much useful work, calculate its efficiency. So useful divided by total, it's about 24%. And that's typical. Petrol engines aren't very efficient. They produce lots of heat energy. Okay, they're not very efficient, and quite a lot of sound as well, but mostly heat. Secondly, this bulb has an efficiency of 85% and it's rated at 20 watts. So that's the power input, 20 watts. What useful energy transfer takes place? Well, electrical energy goes in and usefully light energy comes out, and then the wasted energy is heat. What is its useful power output? Well, I've rearranged the equation now. So basically 85% of 20, or 0.85 times 20 is 17 watts. Let's talk a little bit about thermal efficiency, because you need to know it. Now, this is a picture of a house taken with a special camera. It's called a false color image. Now, this image, basically the hot bits are red, the cold bits are blue, and it's telling us where heat energy is escaping from the house. So looking at the house, heat energy seems to be escaping from around the top of the house because hot air rises, and also an awful lot from the windows and from the doors as well. But also from the walls, heat energy is escaping from the walls. First of all, why is it sensible to try to reduce the amount of heat escaping from a building? And if you don't know that, then have a little word with whoever pays your heating bill. Okay? How might this be done? Well, several ways. This is an experiment that you should be familiar with. I think it's one of your practicals that you have to do. Put the same amount of hot water in each beaker. Now, I've given each beaker a lid because I'm not interested in heat escaping from above, just from the sides of the beaker. So I've put a good insulating lid on the top, but then around the sides we have nothing. We have cotton wool, we have card, we have newspaper. What you could do as well is compare different thicknesses of newspaper. And what you will find is that some materials are better thermal insulators than others. Okay, they stop the heat from escaping. They are thermal insulators. And that's because their thermal conductivity is smaller. If you like, they've got more thermal resistance, but don't write that. Their thermal conductivity is smaller. Also, the thicker the insulation is, then the less heat is lost. Going back to our house, there are three main ways that houses are insulated. You have in the loft, you've got loft insulation, probably some kind of fiberglass. You've got double glazing, stops heat escaping through the windows, or stops a lot of heat escaping through the windows. And you have something called cavity wall insulation. Interestingly, what all of these three methods do is they trap air, and still air which is not moving, is a very good insulator. Okay, it has a low thermal conductivity. When houses are built now, when they build new houses, there's loads and loads of regulations. The walls have to be very, very good insulators. You have to have double glazing. You have to have loft insulation. And the idea is that whoever owns the house will be saving money, but also the country will have to burn less fossil fuels. So the fossil fuels that we have will last longer, and they won't contribute to global warming as much, etc., etc. Loads of it kind of regulations now when new houses are built. Small windows as well. If you look at new houses, they've got small windows.